Доброго дня, шановні колеги.
Добрий день.
Доброго дня.
Здравствуйте, Мария.
Добрый день.
Очень приятно слышать вас.
Рада, что вы смогли подключиться.
А конференція проходить все ж таки офлайн, виходить, так?
Половина на половину.
Ага. То все-таки виїзд відбувся.
Да, там вже компанія дуже така велика, потужна.
Я зрозумів. То ми тільки виходить, що не зміг приїхати, то значить так. Я зрозумів.
Да.
Ясненько. Бо якось мені дзвонив був, з Григоровичем говорив, то вони планували виїжджати, але я то не зміг був. Ну таке, ясненько.
Скажіть, пане Юрію, а ви не плануєте робити доповідь?
Ну, я там написав, якщо можна останній день, десь там пару хвилин, якщо ні, то вже так. Я тут
Добре. Ви підключаєтеся, ми там вас вже включимо обов'язково.
Добре. Я там написав листа на організаторів.
Да, я бачила.
Чесно, я десь прошляпив. Щось датою, якось я говорив з Григоровичем, і мені щось запам'яталось 20-те число, щось таке. І я так, чесно, з цими роботою, знаєте, і воно щось все в роботі постійно десь його прошляпило. Це просто побачив, що лист знайшов. Якщо можна 14-го, то я готовий.
Добре.
Добрий день.
Добрий день.
І доброго здоров'я.
Добрий день.
Алло.
Здравствуйте, Александр Григорьевич.
Добрий
Рад вас
день.
видеть.
Доброго дня, Олександр Григорович.
Мікрофону.
Доброго дня, пане Юрій.
Олександр Андрійович, дякую. Я теж приємно приєднатися
Доброго дня.
до конференції.
Народ, є проблема з інтернетом.
Всім доброго здоров'я. Олександр Григорович, у вас проблема
Так.
з зв'язком.
Трохи там щось воно шпангує. Ну, зато бачимо.
Доброго вечора.
Доброго дня. Чи у вас там уже вечір? У нас ще день. Доброго дня.
Так.
Кількість учасників 13. Можна розпочинати.
Насправді треба збільшити до 14.
Регламент по кількості.
Ну, вже проскочили, вже більше, вже.
Не більше.
Якщо приєднається.
Так, ще раз, зараз. Ага. We have problems with internet. Марія, чи Тарас?
Так.
Тарас,
Так.
Тарас,
Так, я вас чую.
слухай, зв'яжися з Оленою Капустян, тому що тут вибиває інтернет постійно. От я маю там тут про інтернет.
Вас через 2 букви чути.
Олена не пізнала Капустян?
Немає.
Так, я якраз Олені Анатолійовні телефоную.
Пізналась, ні?
Зараз приєднуюся, зараз я їй прискину посилання. Зараз, секундочку.
Будемо відновлювати спостереження. Дуже цікавий розділ. Неповні дані. От там був всередині доповнювати. Одне з 3.
Якщо при біді Олександр Григорович може виступити там,
Так.
а нам прислати відео.
Будеш транслювати зараз, тому що Олена не підключена. Звук є?
Уже краще чуть, уже майже практично все.
I have another computer
О,
now. Дорогі колеги, дорогі друзі,
Dear colleagues, dear friends,
я вітаю вас з відкриттям чергової конференції прийняття рішень в умовах невизначеності.
I greet you
Recording in progress.
opening the conference.
Ми тут в Поляні зібралися з невеличким колективом. Десь нас чоловік загалом 20 всіх. Ось ряд професорів.
We are here in Polyana, in Zakarpattia, Ukraine. Also here we have few professors on site and happy to see other persons online.
Я хочу спочатку подякувати нашим спонсорам, завдяки яким ми проводимо цю конференцію. Це насамперед Петро Коцур.
I want to thank you to our sponsors that are helping to organize our conference. And the first, I want to say big thank you to Petro Koncur,
Ігор Ханін.
Igor Hanin.
Your sponsor is here conference, our conference. Ну і учасники конференції, які теж спонсорують її відкриття, і не тільки відкриття, і продовження.
And also I want to say thank you to all other persons that also are sponsoring our conference from the start and to the end.
Звичайно ж, наша конференція не змогла би відбутися, якби не наші Збройні сили, які героїчно борються з московськими загарбниками.
And also I want to say thank you to Ukrainian military forces that are now fighting for us with Russian occupants.
Я пропоную хвилиною мовчання вшанувати пам'ять полеглих наших воїнів.
1 silent minutes for our Ukrainians that died during the war. with Russia.
Yeah. За той час, коли наша конференція не проводилася, на жаль, декілька учасників і учасників навіть з програмного комітету і з організаційного комітету пішли з життя. Це професор Королюк, професор Єрмолєв і професор Лебедєв. І доцент Печельницький. Давайте вшануємо хвилиною їх пам'яті.
During last times that we didn't have conference because of COVID-19 and because of war, unfortunately we have some of our colleagues that passed off. So let also have a silent minute for this for our colleagues.
Я бачу, до нас приєдналися багато учасників, в тому числі з-за кордону, із Турції. Я особливо радий бачити Абіля Ягубова з Турції, який був постійним учасником нашої конференції. І є.
I see now that a lot of colleagues joined the meeting, and a lot of from foreign countries. I want to say big greetings to our colleague from Turkey, Abil.
Також колег з Азербайджану, колег з Литви, де ми так мовити не один раз зустрічалися в Литві, в Азербайджані під час проведення конференції.
Also, thank you to our colleagues from Lithuania and from Azerbaijan.
Я надію, що наступну конференцію нам вже вдасться провести офлайн, і можливо, що якщо буде така можливість за кордоном України, і в Україні нормально, і можливо, що і в Україні.
I hope the next time we'll be able to have a fully offline conference, and hopefully maybe we'll be able to do this conference not only in Ukraine but in our some other countries outside of Ukraine.
Ну, і давайте тоді почнемо. Можливо, хто хоче сказати декілька слів.
Maybe somebody wants to say a few words and to add something.
Again, can I tell something about some words about
Professor Kapustyan.
Okay,
Yes.
hello. Hello, thank
Would
you.
you like to yours, yes?
Yes, I'm here. Thank you very much for this introduction. My name is Elena Kapustyan. I'm Deputy Dean of Faculty of Computer Science and Cybernetics, Taras Shevchenko National University of Kyiv. I'm very glad to invite you all, guys, and on behalf of our Dean, let me express my great admiring of your work, because I understand that it's not so easy, not this time to meet together. And I see many guests from another countries, and from Azerbaijan, from Turkey, from Poland, and from Lithuania, and other countries. And I'm very happy that our scientific life in this very, very hard time for all of us, we continue this scientific work, and I'm very happy that many of us can be at this conference offline. It's very good. I know that there are lots of people now in Polyana. Guys, hello, and please, hello. And I'm very glad to meet you all here, and I expect that you will have everything you expect to get from this conference.
Thank you very much. Thank you, Maraj. I have proposed Olena Kapustyan, chairman now today conference. What is Olena?
Okay, thank you very much for this a great honor to be a chairman right now. I understand that Professor Nakonechny has some problems with connection. Yes?
Yes.
Okay, so let's start, and please let me see you some presentation from our Lithuanian colleagues because they can't be with us this day, but they sent some invitation. But let's do this technically after some words of our dear friends and dear guests. So can I can I give the word for Natik Ibrahimov? Can we tell us something, some greetings maybe?
I don't know whether Ibrahimov here or not.
Yes, he's here. He's here. Please, Mr. Ibrahimov, maybe you want to say something to this conference right now.
Professor Arabi, not.
He will not attend the meeting, unfortunately.
Okay, maybe okay. So no problem. So let's see some greetings from our Lithuanian friends.
We not hear you well.
Resilience is a phenomenon that occurs as a result of natural human reactions to adapt to various challenges through the ability to cope with or respond to threats. Resilience is not just a passive human reaction to threatening. Therefore, it is argued that resilience can and must be continuously developed. Taking into account the specifics of the work of military personnel and the increased needs for resilience training of military personnel, the aim of the study is to identify the challenges and opportunities for resilience training of Lithuanian military personnel. The qualitative method of experts interviews was chosen for the study. The study involved 8 experts. They were selected according to the following selection criteria. Military psychologists currently working or serving in the Lithuanian Armed Forces with at least 2 years of service in the Lithuanian Armed Forces and related to military resilience training. The interviews were aimed to identify the main challenges in developing resilience for military personnel. It should be stressed that the research focused on the general development process and its organization, rather than on the context of the training process. Therefore, the conclusions presented in this report are mainly analyzed from a managerial point of view. In the analysis of the resilience training process, the informants confirmed that the importance increased significantly. They stated that until the war in Ukraine, resilience building was not a priority, but now things have changed. The importance of resilient development is understood by everyone. The war in Ukraine has increased the importance. Let me present the challenges identified during the research related to resilient development in the Lithuanian Armed Forces. The informant stressed that the resilience training system has not yet been developed in the Lithuanian Armed Forces. This was identified by the participants as the main disadvantage, despite the fact that the Lithuanian Armed Forces provide a large number of psychological trainings every year. Most of them, according to the analysis of the programs and the opinions expressed by the informants, focus on suicide prevention and stress management. The analysis of scientific source and interviews with informants have confirmed that the development of resilience is a complex and long-term process. It depends on the individual and his or her personal characteristics, as well as on the environment around him or her. This environment could be, for example, family, organization, team, etc. This shows that resilience building is an ongoing process that takes place at different levels. Informants pointed out that resilience training can only be effective if the individual can measure and evaluate this progress. This is the main problem identified here, the lack of not only systematic resilience development, but also an evaluation system that allows one to measure progress or changes in the development process. The analysis of the evaluation problem has highlighted several problematic aspects. First, to measure change or progress, it is necessary to measure one or the other phenomenon. Currently, many trainings or exercises are conducted without measuring the participants' progress. On the one hand, there is an identified problem related to the effectiveness of the exercises conducted by the instructors. Several informants indicated that they do not know what the value of the exercises they provide and what benefits it brings to the participants. In other words, they provide training in an automatic way, without clear motivation and without a clear and measurable outcome. On the other hand, participants cannot measure the change in their resilience because there is no assessment procedure at the beginning of the training, and often participants themselves do not even think about it and do not realize what change has occurred in their resilience or in their other competencies. Therefore, it is concluded that all training should have a clearly defined system to measure evaluation quality. This raises another issue, the need to improve the competences of the personnel involved in the training of soldiers in the field of resilient training and evaluation. Military psychologists were asked to assess how many hours are dedicated to the development of resilience in the Lithuanian armed forces. They indicated that there is no time allocated for this in the ongoing programs. However, they stressed that much depends directly on the personal attitude of the unit leadership and the individuals who organize and deliver the training. For example, in the basic soldier course, which develops essential to soldiers' military competences, the resilience of soldiers is also fostered. Measurements carried out as a part of project carried out by the scientists from Military Academy of Lithuania have shown that the resilience of soldiers before and after the course has changed. It means it has increased significantly. This shows that resilience development takes on much greater importance when measured purposefully. The informants indicate that resilience development in the training system could be organized in the following way. 3 hours for resilience training, 2 hours after 6 months to discuss and measure change. The key to this approach is to know what I do and why I do it, and how to measure it. The mutual reflection of the participants in the training process is extremely important in the development process. However, according to the informants, pulling soldiers out of service for additional training alongside the main military training is currently a problem. To summarize the results, the most significant changes should be made at the highest level of management of the training process in the Lithuanian armed forces. This should be done in 2 directions. So the first one, to establish a resilience education system in the Lithuanian armed forces by developing a resilience assessment methodology and by providing systematic and specific training time to all Lithuanian military personnel. The second one is to organize training on resilient development assessment for personnel involved in the education and training of soldiers. So it is likely that these improvements will help to strengthen resilient development in the Lithuanian armed forces. So thank you for your attention and good luck.
Thank you very much. It was very interesting topic. So let's say thank you to our participants from Lithuania. And now I have our schedule, so I can invite you all under this list. Okay, so now please let me invite to report Professor Martiniuk, Vasil Martiniuk, please. Professor Martiniuk from University of Belskobala, Holland. So do you need some assist to do your reports? Maybe you need to share screen or something else.
Thank you. All is okay. First of all, I'd like, on behalf of University of Belskobala, where I'm a head of Department of Computer Science, to express our attitude and our appreciation to organizers of the conference and to the possibility to participate at this international meeting. Our report will be devoted to our the latest result which we obtained within the project devoted to applied artificial intelligence. And I'd like to share my screen, if I can. Can you see my screen?
Yes, we see you.
Yes, and the report will be devoted to the stability research of square lattice model with spatially varying diffusion. The work was fulfilled within the framework of the project The Future is in Applied Artificial Intelligence. The project fulfilled in the consortium coordinated by University of Belskobala, and the aim of the project is to join together higher educational institutions, business, in order to address the competencies and compatible job profiles. The collaboration will provide innovative solutions for training of ICT specialists, and primarily in the branch of applied artificial intelligence and machine learning. Here we use the term applied artificial intelligence, meaning the focusing on real case study, on use case study, and competence-based education. The main goal of the project is to get for students to get acquainted with the possibilities of artificial intelligence systems for solving problems in management, industry, engineering, administration, and education. The main ideas are that developing joint university training program in the field of artificial intelligence with theme or similar curricula for a master science degree. Usage of appropriate competence-based flexible forms of training, developing a virtual laboratory for students, researchers, and experts, sharing and working on real problems and use case study. Project pillars are conceptual, technological, and human aspects to be considered. We have some results that we expect to get. And first of all, the main idea, the main goal is to join together higher educational institution and business for the purpose of getting real competencies in their branch. In this part of the project, I'd like to present our result concerning some use case that should be included into training course, and it is related with manufacturing network design. This aspect of what is also included in the cyber-physical system design, and the current state of the art in the area of Industry 4.0 requires designing large-scale systems that should be informationally controlled and with the cutting edge of the industry. Here we extend the well-known transportation problems with manufacturing logistics. We consider separate production sites at the nodes of the lattices, and actually here we apply well-known reaction diffusion systems which are based on lattice models. That is, actually we consider temporal spatial models which should be which will be applied for manufacturing network design. The objective of the work is to develop and study the temporal spatial model for manufacturing network using compartmental dynamics for production sites and spatially variant diffusion and transportation. For this purpose, we apply differential equations with time delay on the squared lattice. Here we consider the manufacturing network incorporating the logistic production sites which are located on the nodes of a squared lattice. We consider for given instant of time the resources that should be used for producing the product, and consider the value of the ready product which is produced and stored at a certain production site. The model takes into consideration a series of rate parameters, and we will present these parameters later. And the main idea is considering squared lattice with varying delays. Such model allows us to consider the transportation of the product between the sites, and as I said, we consider here reaction diffusion system which is based on squared lattice. The model is based on a series of assumptions about the interaction of the sites with respect to product, and we consider a lot of assumptions about the origination of rate parameters of the model. From viewpoint of the system, we obtain the first equation for the resources which will be used. This equation also incorporates the special operator. It is similar to the diffusion operator in continuous case, and consider some delay which are required for the production of units of productions. Then the second equation is for product itself, F sub AI. We consider some initial conditions for these production sites, and this the expression for special operator for this model. Here we take into account, as it was shown in the figure, the interaction of the four neighboring sites, and interaction and exchange of the resources between these logistic manufacturing sites. Then our research was devoted to stability analysis of such model, and here we have used our previous results regarding dynamic lattice models, and here we tried to extend these results to variant diffusion. The first result was related to persistence of the model. It is related to the existence of positive solutions of the system, and we have gotten the conditions for the persistence and for in a clear form, using the values of the especially variant diffusion of the model. Then the next research was devoted to extinction of the solution. It means that we try not to get the situation of the omitted the resources or lost in all the resources that will be used for producing a product. And we have managed to get such result using the function which depends on the number of cells in the lattice, namely the value of capital N, and the condition that we require for that the resources not disappear in the entire model can be presented in such a function. Then here we present the proof of such result. Then a lot of attempts were devoted to getting the stability conditions, and for this purpose we have applied well-known techniques using Lyapunov-Krasovsky functional for a lattice dynamic system. And I think that in the nearest months we will publish these results as papers in some of prestigious journals. So I think that this over for presenting my result.
Thank you very much. Thank you very much, Professor Martiniuk, for such meaningful report. So, dear colleagues, maybe you have some questions to our speaker. Please, we invite you to ask speaker to feel free to speak, to talk with our speakers.
Okay, I have some question.
Perfect.
Dear Professor Marcinyuk, my question is dealing with type of your model. So you consider size and what is time of communication about any points of your lattice? Is your model real-time model, or maybe time is discrete time?
Thank you for a good question. It is a continuous time model, but in our works we have considered, and we will consider also the discrete time model based on difference equations and even the equations on time scales. We are also developing such results. Thank you.
Okay, thank you very much.
Thank you for your asking, and maybe you have some questions, colleagues. Okay, thank you very much, Professor Marcinyuk.
Thank you very much.
But dear colleagues, our open ceremony was very short. So please, let's make some photo for our history of conferences. Let me ask you to switch on your cameras. Let us see you all to make one common photo. Oh, thank you very much. I see you all. Okay, and maybe some more colleagues. Mikhailo, hello. Maybe some our guests from other countries. Let us see you all. Let's make some common general photo for our conference. Let's make some history of our conference, because if we have many photos, you see that our conference has its own life, and we can put it to the internet site of our conference, and you will see yourself and remember this conference. Okay, so please switch on your cameras to make some photo. Guys, where are you all? Okay, so let's make Mikhailo, hello. Professor Cheny, we are waiting for you. Okay, guys. Okay, so let's make some photo. Let's say PDMU, and let's make some photo. Taras, please. Okay, thank you very much, Taras. Is it okay? Is it okay?
Хтось демонстрації. No. Yeah, it's okay.
Okay, thank you. So let's continue our conference. Let's continue our work. So please, I see under our schedule that we have the next speaker, Professor Gadiev. So, are you here, Professor Gadiev? Or maybe someone from your research group? Okay, when you will be with us, you will tell us, and we invite you to make your report. So please, the next speaker, Professor Bakrushin. Okay, I understand that now is a working day, and everyone has some lectures or something else. So we will wait you in the evenings. So please be with us. Okay. So the next speaker is Professor Pankratova. Okay, I understand that. Are you here?
Professor Pantato make tomorrow report.
Oh, yes. Okay. Thank you for your notice. Okay. So let me invite the next speaker, Shivchuk Yulia.
Пишіть.
Okay. Hello.
Happy to meet you all. And today I want to present our result of our research with
Юля.
Yep.
Юля. I would like few words about this problem.
Okay.
First time. Можеш перекладати. Значить, проблема стресу. Проблема стресу зараз дуже актуальна, особливо з нашими з війною.
Problem of stress is very important now if to take into account that we have a war right now.
Дуже багато наших військових, вони мають синдром стресу.
There are a lot of our soldiers that have syndrome of stress.
Ми зараз ведемо таку тему сумісно із Литвою, де ці проблеми розглядаються і вивчаються.
Now we have together with Lithuania the team where we are trying to solve these problems together.
Тут є декілька проблем. Ми розглядаємо в нашому доповіді, ми розглядаємо проблему опису кількості людей, які мають синдром стресу.
We have several problems here, and we try to count and to have count of people that have this problem.
Як вияснення, що проблема стресу стрес це є хвороба.
So, as scientists proved, stress is illness.
І тут виникає проблема, чи передається стрес до інших людей, чи ні. Зовсім недавно було вияснено, що стрес передається іншим людям, і за це відповідають так звані зеркальні нейрони.
Here is some assumption that stress can be transferred from one person to another person. That is why it's very important now in this era.
Це значить, якщо хтось має синдром стресу і поруч знаходиться інша людина, то вона теж буде мати подібні симптоми.
It means if somebody has this illness and other person is near this person, it's very possible that this other person also will have the same problem in some time.
Звичайно, тут ми розглядаємо декілька моделей. Одна модель повільної динаміки, а друга модель швидкої динаміки.
Here we consider to investigate two models, one with slow dynamic and another with fast dynamic.
Швидка динаміка може бути пригодна, наприклад, для ситуації паніки.
Fast dynamic is something that can be in situation of panic.
На нашу думку, для вивчення цієї проблеми підходять моделі популяційної динаміки.
For our consideration, here we can apply models of population dynamic,
які враховують процес передачі синдрому стресу іншим людям.
That considers the process of transferring this illness to other persons.
Врахування процесу передачі приводить до того, що ці моделі є нелінійними.
And these models are non-linear.
І, звичайно, тут нелінійні моделі можуть мати, самі прості моделі нелінійні можуть мати необмежені розв'язки.
And even simple non-linear models can have simple solutions.
Наприклад, рівняння dx по dt дорівнює x квадрат.
For example, equation dx
по dt equally x square.
Equal x square.
Це рівняння за скінчений час іде на нескінченність. Розв'язки цього рівняння за скінчений час спрямує до нескінченності. І тому, на вигляд, прості рівняння повинно, так мовити, вивчати з цієї точки зору. Існують розв'язки, не існують, обмежені чи ні.
And we need to if this solution is, or for example, if doesn't exist in this situation.
На щастя, ті моделі, що ми розглядаємо, вони якраз мають позитивні розв'язки і розв'язки, які обмежені на всій осі.
In models that we are trying to solve, we have positive solutions, and we have the right solutions to the all axes.
Ну, але для того, щоб спрогнозувати кількість людей, які мають синдром стресу, ми повинні знати праві частини, які, як правило, залежать від невідомих параметрів. І тоді виникає проблема спочатку оцінки цих параметрів за спостереженням.
But to solve this problem, we need to know right parts, and we need to know how. We need to know from the beginning identification problem. To know from the beginning of the estimation of these parameters.
І друга проблема, яка тут може виникати, це керування або кількістю людей, які мають стрес з цілею їх зменшення.
And other problem is how to control count of people that have this stress problem and how to decrease this count.
Для інших цілей ми використовували такі моделі з професором Марценюком.
For other needs, we use the same models with Professor Martz.
З професором Михайликом.
With Professor Michalik.
Ну, і, звичайно, з Юлією Шевчук, з якою ми маємо, як з Василем Марценюком, монографії по цій тематиці.
And also with Yulia Shevchuk, with whom and with Vasil Marcenyuk, we have monography for this theme.
Ну, а деталі того, що зроблено в цій роботі, вам представить Юлія Шевчук.
And details what have been done for this work, Yulia Shevchuk will present you.
Thank you for this interesting report.
Please start.
Thank you. So, I must show you our results, and in this presentation we propose results for first model with slow dynamics. You can see this nonlinear differential equation. It's with initial conditions, so we have some many problems for Cauchy problems, and we say that we want to work with different number of groups. So before Alexander Grigorovich said about we want some evaluate stress in maybe soldiers, so for example in civil population, and we can maybe make different groups for our investigation, and we use this index E for our different group, and we say that we want use a different number in this group, and we want work with nonlinear dynamics in this investigation, and say that we have some external influence for our stress. For example, it can be news or some other external influence. And we have this parameter gamma E. This is the rate of change of number of persons under stress without some external stress. And we didn't work in this presentation with our condition for non-negative solution or other, but we have a special case of this basis model when we work only with one group, and we have this problem of Cauchy, and then we can have this solution is this easy form, and we can sometimes rewrite in zero equation, zero value if we use a special beginning equation condition. So, as said Professor Nakonieczny, we have a few problems, and we will discuss about first problem. This is we know parameter gamma E, but we want to estimate some future value of people under stress. It's if in moment one after our time of investigation. And second problem, when we work with observation for these values, so we can maybe checking these people under stress, but we propose that we have some unknown errors with this observation. So we also want to find some predictive values for our number of people under stress syndrome. In the first problem, we use some special nodes and working with this maybe some unusual type usual type work with differential equation. We use something look like difference equation, and after all we use this formula and say about we can making some a posteriori set for our parameter gamma if you know this some inequality. So as you can see from this inequality and this formula, we have the view of our a posteriori set. So we know some minimal and maximal value for our unknown parameters, but when we use this posteriori set, we can make some predictive estimation. As you can see here, we show our formula for average predictive estimation. Here we use some our measure for our a posteriori set, but as we will show how we work with this measure in maybe easy exercise. So here we use this measure, and as you can see, we work with some integral with our function or number of people under stress. Also, as you can see, we work with guaranteed predictive estimation, and we propose formula for error guarantee estimation. So I hope many people can show something similar for previous investigation, Alexander Grigorovich. So second problem, we work with our observation of number of people under stress. We also work with with any number of group, and we work with some time period. So we propose that we have observation, we have unknown number of people, and we have some noises of error of observation. We can rewrite this formula in some matrix form, and this our unknown our errors, we propose that we bounded some value decay, and from this inequality we can write a posteriori set, as you can see. If we have a posteriori set, we can propose and guarantee predictive estimation. On this slide, we copy this formula, and we can rewrite our formula for this situation from error guarantee predictive estimation. So, and our example, as I said before, we work with one group of people under stress, some FQ, PQ, for example, and we work without some external influence. Only maybe native process of external spreading our stress, some maybe use of state. So we also propose that we work with some observation of our value of number of people under stress, and we have typical inequality for our errors. So after all, we can find our solution, because it is typical maybe our equation, and we work without non-stationary parameter gamma. And after all, using this solution, we can propose our posteriori set. And after all, we can use this posteriori set for finding our estimation. In this slide, you can see our formula for finding guaranteed estimation. So this formula and error this estimation. In the bottom of our slide, you can see a more detailed formula for finding this number, maximum and minimum for our number of people under stress, and we rewrite some maybe big and strange view our right side before we work with some integral, but here we can solve this integral and rewrite this formula. Here you can see a formula for average predictive estimation and average for this estimation. And before, as I said, we work with measure for this a posteriori set, but we here work with one dimension set, and we can rewrite this measure for distance, and we work with this difference and work with integral that bounded these two values. So we have this formula for average predictive estimation. So here's maybe all that I want to say you today. We have few references for our presentation. So as you can see, we work with Alexander Grigorovich on these problems, simulating Bekesina also many times using these problems for her investigation, and we very productive work in our joint Ukrainian-Lithuanian project. So it's all. Thank you for your attention.
Thank you to speaker. Difficult times dictate us some current topics. So you see that this topic is very actual, and it needed to be investigated. So dear colleagues, maybe you have some questions to our speaker. Please.
Okay, I have some small question. Yulia, okay, let's consider two persons. One under stress, another without stress, okay? And stress is transported from one person to another. And did you consider that stress is transformed immediately, or is there any delay in the process of transformation?
No,
Of
no,
the stress
mute.
spreading.
Switch on your microphone, please, Yulia.
Okay, sorry, maybe I don't understand your question, but if I share my ecran, no? One moment. We propose that our influence one person to other work with this parameter gamma. So it's maybe if, for example, how external spreading stress in one family or from friends. So
Okay. Thank you very much. And do you consider any level of the stress, or 0, 1, under stress, without stress?
Well, no, it's a basic model, but we can modify this model for different number of levels of the stress. But I
Thank you very much. Thank you very much.
I saw different questionnaire for calculate anything, but stress is some mechanism of organism, so we can't maybe in a scientific maybe way some evaluate stress of the organism, because it's some biological process, some minding process, physics process, and I think it's very hard problem for us.
I can tell that we investigate the systems without delay. It's just like our CIR models, so we don't investigate some delay models. Okay. So thank you very much, Yulia. Yes, for this current topic. And dear colleagues, please feel free to ask our speakers, because now we have this informal meeting. We can speak each other about our research directions, maybe about our research areas, about topics. So please feel free, ask our speakers, our participants, to know about our research investigations, to spread our ideas and to know something new for all of us. So under our schedule, I see that some of our colleagues in Carpathian Mountains, where our conference now is, they have some problems with internet connection. So they will have the local section there. And as I understood that today some speakers will make the reports there offline. And maybe Professor Chabanyuk, he's here, yeah? He's not here. He is at the Carpathian Mountains with another section of this conference. And Professor Cherny too. Yes? Okay, so let's move under our schedule, and now we can hear such reports of Drin. I'm sorry, is it okay? The name is Drin. Can we hear such a report? Report with a topic of this report is the Cauchy problem for quasi-linear equation with non-stationary diffusion coefficient. Okay, so unfortunately, maybe not this time. Maybe I know that some reports you can hear some reports tomorrow on the next section, and so please let's have hope to hear such reports next day. And maybe we have our next speaker, Jaladova, Professor Jaladova, or with her co-author Bartosz. Okay, so dear colleagues, maybe someone wants to tell something to another participants. Maybe someone wants to have some report. Maybe someone is not in this schedule, so please feel free to make your report, because we want to know what's something new in your research topics. So you can tell us about your own research topics. Okay, so as I understood that our schedule is finished. Maybe we have some speakers from tomorrow to this day. Maybe they want to tell something. Okay, so as I understood, now our meeting for our, how to say this, speaking part is over. So dear colleagues, let me tell you one more time that I'm so happy and glad to see you here all, and let me invite you with let me to tell you that this conference is very important for our faculty, and you know that now we need to continue our scientific work, because it's very, very important to continue despite of these hard and heavy times. So I'm happy to see you all, and please have a nice day. Thank you for your joining us, and let's meet tomorrow at this time to know something new. Okay. Maybe someone
Thank you very much. It was very interesting. Thank you very much.
Okay, to me too. Thank you very much.
I'd like also to thank for good coordination of today our meeting.
It's to Professor Nakonechny. Okay, I will tell him about your. Thank you for him. Okay, thank you. Okay, dear colleagues, nice to meet you. Nice to see you.
Have a nice day. Have a nice day. I'm very glad to see Professor Martinyuk. Have a nice day.
Thank you. Thank you.
Okay, bye bye. Bye bye, dear friends.
So bye. Have a nice day.
Bye.